Good day, grade 12s, and welcome to the second segment of dealing with the hyperbola. And boys and girls, in this section, essentially what we'll be doing is we will be looking at determining the equation of a hyperbola given the asymptote and a point on the graph. So essentially in the exam, you will be asked to determine the equation of an hyperbola, and you'd find that in the question we've given you the asymptote, or we've given you an image of the graph, and you already have the point of intersection, as well as you have a point that lies on the graph. So the first thing you're going to do, boys and girls, as stated here, as I've written, what you're going to do is essentially, firstly, you're going to get the equation or determine the equation of the asymptotes. So x is equal to negative p, as well as y is equal to q. From there on, you're going to determine the p value as well as the q values and substitute them into the equation. Now, it is very important for us to remember that with the p value changes. So if our point of intersection is negative 5, 4, then our p value that we substitute into the formula is 5. And if our point of intersection, for example, is 5, 4, then the p value that is substituted into the equation is negative 5, because p changes value. It changes the sign. Just remember that, boys and girls. Then we substitute the p and q values into the equation, and we then take the point that lies on the graph. So this point, xy, and we substitute it into the equation, and we solve for a. And last but not least, boys and girls, we rewrite the equation into y is equal to a over x plus p plus q. Okay, now let's quickly work through these examples so that we could quickly see what I'm talking about, and we could just put everything that I've said and the theory that I've given you, the content that I've given you, into practice. Okay, here we go. Question 1 second. Question, first question is question 1.1. Okay, so we have this. It says in this equation, we've got the diagram below is of a graph, and they give us the formula of a hyperbola, and they say to us the point P is on F. So the point P is a point on the graph, and we have the asymptote y is equal to 2. So in this case, boys and girls, remember I said we have our standard form. Our standard form is y is equal to a x plus p. Excuse me. Just give me 1 second, boys and girls. I'm just having a bit of a difficulty with my pen. A x plus p plus q. Now, given that we've been given this equation without a p, that should tell you that the value of p is equal to 0. And the fact that when looking at this graph, the image given, the graph touches everything but never touches this line, which is 0. So that's your vertical asymptote. And we're also given the horizontal asymptote, y is equal to 2. Vertical asymptote, x is equal to 0. Now, that being said, boys and girls, I want us to then look at the equation. Look at the question and answer. Question 1.1 asks us, determine the equation of h. So the equation of h, as I've said, y is equal to a x plus p plus q. So we have the point of intersection, 0 and 0, 2. So that's for the axis of symmetry, right? Not the axis of symmetry, where the asymptotes intersect. That being said, we also have a point that lies on the graph, and that point is point P, which is the coordinate 4, 3. So let's quickly substitute in what we know. So given this formula, we already have our what's it called again? We already have our y. We already before we even start off the y value, just need to write down y is equal to a x plus 0 because p is 0, and our q value is 2 plus 2, and then we take this point, boys and girls, this point. Forgive me, boys and girls. Then we take this point, yes, because point P is the one that lies on the graph. Point P, and you take point P, and you put it into your formula. The y value is 3a 4 plus 0 plus 2. We have 1 is equal to a over 4, and the value of a is equal to 4, essentially. And when a is equal to 4, we can rewrite the equation. Therefore, y is equal to 4 over x plus 0 plus 2. And that's the equation of the graph. So you get a mark for your final answer, a mark for getting to A, and a mark for substitution. That's 3 marks. That's 3 marks. Okay. Then it says here, question 1.2. Question 1.2 says the coordinates of the x-intercepts of h. The x-intercepts of h. So x-intercept, make y equal to 0. So x-intercept of h. That being said, let's see. X-intercept of h, let's see, okay. X-intercept of h, make y equal to 0. So therefore, we will have 0 is equal to 4 over x plus 0 plus 2. Negative 2 is equal to 4 over x. Negative 2 is equal to, negative 2x rather is equal to 4, and x is equal to negative 2. Right? Perfect. And we wanted the coordinates, boys and girls. So when it's a coordinate, we put it in coordinate form. So that's rather given to us as negative 2, 0. It's easy. 2 marks. Now, boys and girls, I want us to just quickly add another paper here. I'm adding a paper. Perfect. I added a paper. So then from there on, let's quickly go to question 1.3. 1.3.1. It says, determine the values of x for which h of x is less than or equal to 0. So where is the graph? Equal to 0 or below the x-axis, right? Where is the graph equal to 0 below the x-axis? From here, it's equal to 0, the values of x, and it's below the x-axis until this part, but not touching 0. Okay, so we said that we can see that in the previous question, boys and girls, we solved for the x-intercept, and the x-intercept was negative 2, 0. And we only have one x-intercept, so it's negative 2, 0 here, that point. So now it asks us for which values of the graph is the graph of h of x equal to or below the x-axis. That's how we interpret this, what's called again, this inequality. So it would be from negative 2 up to, but not including 0. Negative 2 up to, but not including 0. Because why? 0 is an asymptote. So therefore, x is an element of included negative 2 up to, but not including 0. Okay. Question 1.3.2 says, for which values of x is the graph increasing? For which values of x is the graph increasing. So essentially, when would a graph be increasing? An increasing function is essentially which values of x is h of x more than 0. So where is it increasing? Where is it above 0? X is an element of. X is an element of. Where is it above 0? X is an element of. From where? X is an element of. Okay, so when is the graph increasing? X is an element of. From negative infinity. Okay, excuse me, boys and girls. Let me just quickly check this out. Okay. So, which values of x is h increasing? Decreasing. So, increasing, when something's increasing, it would obviously be positive and above the x-axis. So, I would say x is an element of from negative infinity up to. Okay, boys and girls, I'll get back to this question quickly. Let's just quickly do question 1.4. Okay, it's got me a bit democard. Anyways, we're all human. We're all human. That's what I'm gonna say. So don't think you can get sly with me. Anyways, it says question P. What's cool question? 1.4 says P is essentially negative h of x plus 1. So P of x go to negative h of x plus 1. P of x is negative h of x plus 1, and h of x we said is essentially P of x is essentially negative 4x plus 2 4 over x plus 2, I mean. That's the new graph. And it says to us, essentially what we're supposed to do is calculate the range. And how does one calculate the range? One calculates the range in such a following way. So boys and girls, we said that the range is y is an element of the reals, but y cannot equal your asymptote. Right? So y cannot equal your asymptote. That being what? What would our asymptote be? Our asymptote would be 2. So y cannot equal 2. So that being said, we just need to take this back a bit. Okay. This pen is acting up, boys and girls. Just 1 second, bear with me. So that being said, in such a case, that would be your new range. And you get your full 2 marks. Now, this is something I